Hey everyone, so this is the second day of the power rule, so just more basic derivatives, making sure we have all those rules down. All right, so here's the do now. Oil is leaking from a tank. The amount of oil in gallons in the tank is given by G of T equals 4,000 minus 3T squared from 0 to 24. Find G prime of 5 using the definition of the derivative. So notice it says the definition of the derivative. This is a practice free response problem. So because it says definition of the derivative, you have to do the limit. So for A, it's going to be the limit, h approaches 0, 4,000 minus 3 t plus h squared minus 4,000 minus 3t squared all over h. So go through and figure that out. All right, so we get 4,000 minus, so t plus h squared is t squared plus 2th plus h squared. If you have different letters, that's fine. I'm going to multiply through by negative 3. So negative 3t squared minus 6th minus 3h squared. And then the second piece, negative 4,000 plus 3t squared all over h. So now stuff always cancels, 4,000, 4,000, 3t squared, 3t squared. So we get, and then we can divide out. So it's the limit as h approaches 0. So I'm going to divide out the h. So I get negative 6t minus 3h. Now I can plug in and I get negative 6t. So that's my derivative. Right, so g prime of t is negative 6t. And I know I'm right because if I use the power rule, a negative 3t, the 2 comes down, I get negative 6, 2 minus 1 is 1. So then g prime of 5, if I plug in 5, I get negative 30. Interpret the meaning in the context of the problem. So the numerator of my limit is hours. Nope, is amount of oil in gallons. So the top is gallons. The bottom is hours. So it's gallons divided by hours. So the derivative is gallons per hour. So at t equals 5, at 5 past midnight, 5 in the morning, the rate of change of the oil is negative 30 gallons per hour. So it's going down by 30. All right, so let's do a little review of yesterday. So pause the video and try this problem. F of x is 4x cubed minus 12x squared plus 2, where f has a horizontal tangent. So it wants to know where's the derivative equal to 0, right? Try it. So the derivative is what? 12x squared minus 24. Horizontal tangent, remember, is where the slope is 0. I'm going to set that equal to 0. I dropped an x. I can factor out a 12, so 12x, x minus 2. So I get x equals 0 and x equals 2. Where is f prime greater than 0? Where is f prime less than 0? So what we're going to do is we're going to look at the derivative. So I have 0, 2. If I think of a number bigger than 2, 3. If I plug that in, do I get a positive or a negative? If I plug that into here, the derivative, I get a positive times a positive. If I plug in a number between 0 and 2, say 1, I get a positive 12 times negative 1, so it's a negative. If I plug in negative 1, that's negative 12 times negative 3. That's a positive. These are just test points, they're not answers. So f prime is greater than 0 from negative infinity to 0 and 2 to infinity. F prime is less than 0 from 0 to 2. We're going to spend a lot of time doing this, so if that was a little fast, don't worry. All right, if f of x equals 5, what's f prime? 0. I think I left that on this slide from yesterday's lesson. All right. Find the x value of the horizontal tangent line. So again, this is just, so what you're doing, horizontal tangent is f prime equals 0. So set the derivative of this equal to 0 and solve for x. Pause the video, do it yourself. This is like my favorite part of this lesson. All right, so I bring the 2 down, so 2ax plus b. That's the derivative. Set that equal to 0. Now we're going to solve for b, subtract b on both sides, and then divide. Oh, hey. I get so excited. Right? What is that? That's the vertex. Think ax squared plus bx plus c is a parabola. The vertex is where that hits. So a really easy way to find the vertex of a parabola is actually doing the derivative and setting it equal to 0. We didn't know that at the time. Connections, yay! Okay, the derivative of e to the x. So now this one's a little complicated. So we're gonna do, we always, whenever we're finding the derivative, the first time, we need to use the definition. So we have the limit as h approaches 0, e to the x plus h minus e to the x all over h. If we plug in 0, we get 0 over 0. So now what can we do to this? There's not a lot we can do. The one thing that we can do is do something to e to the x plus h. So this is the limit as h approaches 0. E to the x plus h is really e to the x times e to the h. Because remember, when you multiply, you add. All right, so then I'm gonna factor out that e to the x. So we have the limit as h approaches 0. So I'm gonna factor out my e to the x. So we get e to the x times what's left. We get e to the h minus 1 all over h. So now we have to use a calculator. We don't really have a good way of doing this. So check out this out in the calculator. So the limit as h approaches 0 of the e to the x is just e to the x. Check this out in the calculator because we don't really have a way to do it right now. It's just 1. So really, really important. The derivative of e to the x is e to the x. Super important. The derivative of e to the x is e to the x. It's its own derivative. So make sure you write that down. Again, memorization stuff. All right, so now I want you to differentiate. What is the derivative of 4e to the x plus x to the third? So the derivative of e to the x is just e to the x. So 4e to the x doesn't change. That 4 is just chilling in front, doesn't do anything. That 3, our exponent comes down, goes down by 1. Write the tangent line to f at x equals 1. So what do we need to write a tangent line? We need a point and we need a slope. So the point, we have 1. What do we get when we plug 1 in? F of 1 is 4e plus 1. So super awkward. That's our y value. All right, what's the slope? Take our derivative, plug in 1. 4e plus 3. 4e plus 3. Super, super weird. Not difficult, but the answer is just so awkward looking. So we go y minus, what's my y value? Now put parentheses because you'd have to distribute to the 1, equals our slope, 4e plus 3, x minus my x value is 1. Again, this isn't hard, it's just weird. It's like having a slope of 4e plus 3 is awkward. Not overly difficult, but just kind of accepting, just kind of go with it. I like to say, just go with it. It's fine, it's correct. All right, is f differentiable at 2? So when we did these the other day, it was like super complicated. So let's check. Because we now have our derivative rules. What is the derivative of f prime? So the top is just 2x minus 9. The bottom is negative 5. So now that I took the derivative, we have to check, is it continuous and is it differentiable? I probably should have checked continuous first. So for the limit as x approaches 2 from the left of f of x, let's see, 2 from the left would be 4 minus 9 plus 11, which is 6. Negative 5, 6. The limit as x approaches 2 from the right is negative 10 plus 7, which is negative 3. So no, not differentiable. Now this is why you have to check. Notice if we check just the derivative, if I did from the left here, I get I get negative 5 and negative 5. So even though the slope from the left and the right are the same, there's a jump. So this graph has a jump at 2. All right, so at 2, we have, it's 6 and negative 3. So this one from the left, slope of negative, so it looks like that. So even though the slopes are the same, because that jump is there, it's still not differentiable. All right, find the following limit. All right, this is terrible. All right, it's really, really, really terrible. You do not want to multiply out that 14. So look at this and analyze it and tell me what this actually is saying. What does this look like? This is the definition of the derivative. All right, definition of the derivative. So we know that by looking at it because it's the limit as h approaches 0. This is an f of x plus h minus f of x all over h. So what we're going to do, instead of we're not going to multiply out h plus 1 to the 14th. That's terrifying. So instead, we're just going to identify what's f of x equal to. Now, this one's a little trickier because it does have a number in it. They're plugging in 2, right? Well, no, sorry, they're not plugging in 2. They're plugging in 1 because it's plus 1. They replaced x with 1. So what does it look like our function is? Well, it's to the 14th, right? So x to the 14th. And then what else? We have this 2 in front. So it's just 2x to the 15th. 2x to the 14th, sorry. That's our function. Now notice if you plug in 1, you get that 2, right? So we're finding the derivative of 2x to the 14th at x equals 1. So f prime, what's the derivative? 28x to the 13th. And then we're going to plug in 1. 28. That's it. So if you see something out of control like this, a limit like this, I'm not expecting you to do it out. I'm expecting you to recognize, oh, that's a definition of the derivative. I can just identify it and do it the fast way. All right. the derivative, so more on the power rule. I mentioned this yesterday. The definition yesterday was only if n was a positive integer, but that's actually not true. It can be any number. It can even be a fraction. There's only one case that for n cannot equal sorry, my brain's -1. No, that works too. N can be anything. Sorry, I'm thinking backwards. N can be any number. It doesn't matter what it is. It can even be a decimal. The rule is exactly the same, all right? The rule is exactly the same. Just be careful here because we're dealing with signed numbers now. So our rule is bring the exponent down front, -7, x, and then subtract the exponent by 1. But what's -7 minus 1? -8, and that is your answer. Okay. F prime, bring my exponent down front, 8 times -2 is -16. X, -2 minus 1 is -3. -1 times 4, so -4, x to the -2. And then last, remember that's a 0, that's a 1, x, so it becomes x to the 0, so just -10. That's it. All right, number 8. Now, in number 8, you cannot take the derivative when the x is in the denominator. You have to move it up. So how do you rewrite 3 over x? 3 over x is 3x to the -1. You have to do that. So then when you take the derivative, it becomes -3x minus 1 is -2 plus 9. And then I'm going to rewrite it. I typically will write my final answer in the same form they gave me the problem in. So like this one, they gave it to me as a fraction. So I'm going to put it back into a fraction problem. Number 7, they gave it to me with negatives, so I left it like negatives. All right, same idea. Try this one on your own. Start by rewriting it. So f is x to the -1 minus 5x to the -2 plus, now the 3 stays in the denominator, that's 4/3 x to the -3. Now I can take the derivative. -1x to the -2. -5 times -2 is positive 10x to the -3. Minus, now the negative, so that becomes 4/3 times -3, which becomes -4x to the -4, because those 3's cancel. Then I'm going to write it back in its original form. -1 over x squared plus 10 over x to the 3rd minus 4 over x to the 4th. And that is the answer. And that's where the power rule gets difficult, just dealing with those negatives. All right, that's it. So we got some practice problems. And then, so we'll do those, 192 to 193. And then homework number 21. So again, it is a lot of homework, but it's really because this is a super fundamental skill that you need. So I need you to practice so that it gets to be second nature. All right, have a great day.